Okay, so we're going to be getting into the next set of panels here. This one is a little bit more of a traditional wall panel style set of panels, whereas before the one we looked at for P1 in the last video installment was for some column panels essentially. Okay, so let's dig in. I'm going to pull up the drafting schedule and I'm going to locate those panels here in my queue. Panels I'm talking about here today. See if I got them here. Proscenium veneer panels, proscenium veneer panels. Should be P5 here. Or wait, sorry, let me just double check. Make sure it's out at the bottom of the list here. Nope, it's right there, P15. That's the one I'm looking for. Let me snag that. I'll put it on my list. I'm going to switch it over to drafting here. Okay, and then we're going to take a look at the print reference and see what it is that we are dealing with here. So A622 is the page number, and the print reference on that page is view 6. So let's go find the job folder for Proscenium. 6434 Proscenium drawings, architecturals. And we're looking for A622. Right there. These panels are right outside the restroom, sort of in a restroom vestibule, like right before you get to the restroom. And we'll take a look at it on the floor plan here so you can see what that looks like. This is view 6 right here. Ignore that note. Found out these are in our scope as suspected. So what we have here is we have some WDV01 panels, which in on-site lingo would translate to veneer 1 or VN1. You can kind of see that there are, let's see, this is a full wall. So you see there are reveals that are actually located this time around. But you can see the different heights that they are requesting to put those reveals. We got EQ here, EQ there, meaning that these will both be the same height, so both equal. We got a 10-inch run of base that looks like it runs below the panels. That is SSO1 for the material. We have a section view right here, which goes through the panels vertically, so that's great. We kind of need that. In the very center, you see this PF08. We'll go ahead and take a look at the plumbing fixture schedule and see what that is. I'm going to say it's probably a water fountain, though. Plumbing fixture schedules, if you're looking for those, we typically will get them, and hopefully they're in this folder. If they aren't, we may not have access to them, but actually it looks like there is an equipment, plumbing, and restroom accessory schedule here. So let's go ahead and pull that open and see what it is that we are dealing with here. Going back again, it's PF08. PF08 on these schedules here. 08, right there. It's an LK bottle filler. If you want to look that up, you may. They may even have CAD files for that as well. It is LK LBWDC 00BKC. Well, I want to go to the actual LK website for this because if I don't, I'm going to end up with like third-party sellers that have this particular fountain, but may not actually have the CAD files for that fountain. It's always better to go to the original seller or the original source, which is LK. That way you can make sure that you're getting all the correct information here. So it's a good thing we did look this up because this is actually, looks like it's most likely going to be recessed into the wall. It's kind of cool, but that means that we have to notch our panels around it then too. So on their website, they should give you a cutout dimension drawing, which they kind of show an example of what that looks like. It says fits within 16-inch on center 2x4 stud wall. So that just means that this sits in between two standard wood studs in a wall. Now, let's look back. There are CAD files here. There's specification sheets, install sheets. So we're going to kind of look at those and just take a look at what they are giving us here for that. Most likely they will have dimensions for the cutout within here. Let's see if they tell us that. Just reading along here. See dimensions, that's the dimensions of the unit itself. So this sheet here doesn't appear to have those cutout dimensions unless I'm just overlooking them. So I'm going to go back to their website and see if there's a different page that might show that. Again, this is part of that research time that you're going to see at the beginning of each project or each drawing that you're working on. You kind of want to dig into the nitty-gritty details of what you're working on. Make sure that you have effectively covered all your bases and made sure you don't have any questions as far as what do you have on your scope for your drawing here. Now, I can guarantee we are not going to be providing this water fountain. It'll most likely be provided by the plumber that's doing all the plumbing and plumbing fixtures for the job. But because it is cut into our panels, this is why it's important to research and make sure that we have the correct cutout dimensions here. So let's see, this unit, blah, 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 blah. Okay, so that doesn't appear to have those. Well, it may actually, but I'm going to keep this open. And they also have their CAD files here too. So we're going to take advantage of that later on when we get into drawing this wall of panels here. The CAD files probably have the cutout dimensions on them, so we'll take a look at that in just a moment here. Okay, anyways, let's keep this page open. We'll go back to our drawing here. And we're looking at these panels here. As you can see, there is no actual grain direction called out. So most times when you see wall panels, it is assumed that the panels are going to run vertically. So the grain should run this direction here. And also, one other thing to note is that a typical wall of panels, we try to maintain specific panel dimensions. And what I mean by that is our company has sort of max panel sizes that we like to work with. So we did talk about this briefly in the last video, but there are our panels, we try to go no more than 48 inches wide typically and no more than 96 inches tall. The reason that we do that is because most materials that you're going to be putting on panels are going to fit within those max dimensions. If you start to go over those dimensions, then you start to run into the issue of you may not be able to get that material in that size. It also becomes a little bit less manageable when you try to install the panels, because as you ship them and start to install them in the field, imagine you're dealing with a panel like this. This is 60 inches wide, so this is a pretty wide panel, 60 inches wide by however tall that ends up being for the EQ dimension there. So really, this is going to end up being a pretty massive panel. It might be worth our time to suggest putting a reveal in the middle of the panel here. We can run that past the project manager on the job and see what they think here, just to get within a more manageable panel size. Now, if they don't go for it, we can actually produce panels that are wider than 48 inches. It's just more of a hassle. We may have to do what's called a shop joint. And a shop joint, what you would be doing there is you have two panels that are coming together and they're glued and attached together in the shop itself. So it looks and feels like a full panel, but really it's going to be two panels, and the joint will be covered up by the veneer, so you never actually see it. So what that would look like is, let's say you have two panels that are shop joined together. Typically what we'll do is we'll put a spline in between or biscuit in between. Biscuits are just like a wooden biscuit that is a woodworker's, it's like a piece of wood that a woodworker will use to attach two pieces of material together. But if we have a shop joint, what we'll do is we'll have something more like this. We'll have that layer of veneer over the top, which is really thin. You won't actually draw that on your print, but just so you can kind of visualize what that would look like, a shop joint is more like this. And if you call that out on your print, we'll call it out as an SJ. You're probably used to seeing FJ for field joint, but a shop joint is specifically for the shop to realize that, hey, this is something that has to be assembled and glued in the shop. So that's what an SJ would be. It's not a very common occurrence, but when you're dealing with larger panels like this, there may be a opportunity to use a shop joint there. So I'm going to leave that be. And again, that's only because this panel is 5 feet wide by however tall we're dealing with here. In between these panels, we're going to be using our standard 1/4 inch spline reveal. Again, we did look at those last time we did a video with panels, but we're going to be drawing those in. They're going to look kind of like this. Oops, one sec. They are going to look similar to this. There'll be a flat piece of material right in the middle, just like this. And, well, these are a little bit wonky, but you'll get the picture though. So that's what a spline joint would look like, and these will be 1/4 inch wide in between these panels here. That is on-site standard, typically, unless noted otherwise by an architect or a project manager, that in between panels we usually will put a 1/4 inch line reveal there. Let's go ahead and look at a couple more views before we move on to actually drawing this, this print. We're going to look at the section view and we're going to look at the plan view. So section view appears to be on page A730, view number 4. We need to go find that. A730, view number 4. Right there. Okay, so it doesn't really do it justice there. It's more of a section through the base. So this is the SS1 base that they're calling out. It does appear they want a 1/4 inch thick metal angle by 1 inch deep. And that's going to run the length of the top of the base, and it separates between the base and the panel there. There's also one thing to also note of here, though, as well, is that they do want the base to be aligned with the face of the panel. So this needs to be in the same plane as the face of the base. Something to keep an eye out for. So that's not really a section through the panel, but a section through the base. So let's move back to our elevation view, and then we're going to locate a plan view for this next. This is on level 1. So let's start by looking at the level 1 construction plan. And again, going back to the days we looked at the print rating exercise we did, you may see it called out as a construction plan. You may see it called out as a partition plan or a floor plan. There are a few different keywords to look for, but yeah, this will be P15 right here. Again, that's no longer a note we got to be concerned about. So this is where those panels live. You can see our elevation call is right there. We are also given an enlarged plan view of that restroom. So we're going to take a peek at that and see if there's any clues as to how these panels are going to be constructed. If there are really no details there, what we're going to do is default to our standard, and we'll go through that here in just a moment. Okay, so here is the enlarged plan view of the restroom panels. So really doesn't show you a whole lot, but you can see the water bottle, drinking fountain, filler right there. So you got that. You've got this double line here. This would be representing the panels here on that wall. And then this double line right here, this is going to be your drywall and wall framing. So, yeah. So it doesn't really give you a lot to look at, but that's okay. That gives us more opportunity to work in some of our on-site shop standards for these panels then. So we've already talked about we're doing 1/4" spline reveals in between panel-to-panel interactions. That's a normal detail for us, unless there's a specific detail they are requesting or need for these panels. When you're dealing with panels that stop at a wall, what we like to do typically is use what's called a full depth reveal. So with that being said, let's kind of sketch in a full depth reveal so I can show you what one of those would look like. It's going to be a little arbitrary. It's not to scale. But what that would look like is if this here is your wall, you would show your panel in this line here, this box here, and then you have your full depth reveal sitting between that panel and the wall. And that is going to typically be 3/4 inch wide at the front. So keep that in mind. Full depth reveals, we usually will go 3/4 wide. This block, typically what I'll do is I'll make that 1.5 inches. That way it is as wide as the reveal plus a little bit past the panel. On top of that, we got to talk about the attachment method for our panels as well. So unless it is noted otherwise, we will usually use what we call our panel cleat. Now, panel cleat, when you attach that to the back of a panel, you also want to include a 1-inch gap between the panel and the wall. That allows for the cleat to be attached to the panel, plus it allows for a small amount of shim space between the cleat and the wall. And that will allow the install team to be able to flush out these panels and make them all aligned and level, even if the drywall is a little bit out of whack. So something to keep in mind. And then, of course, just like most things, your panel thickness is going to be 3/4 thick. The only time that will vary is if you're dealing with panels that are made out of something that is not veneer, laminate, or paint. If you're dealing with panels that are actually stone or solid surface, then you're probably going to end up with a thicker or thinner panel thickness. But for the most part, your panels will be drawn at 3/4 thick, as long as it's just a standard veneer or laminate or paint panel. Okay, so because we're using panel cleats there and we're using our full depth reveals at the corners and our 1/4 inch spline reveals between panels, that makes our lives a little bit easier. So let's go ahead and start by looking for other things here. We're going to look for dimensions to see if we are given, I'm going to close that too. If we're given any dimensions for these panels. It kind of looks like we're given at least a couple of them, but not enough to really have an idea of what we're dealing with here. It's going back to this view, the plan view 2. There aren't really a lot of dimensions here for these panels. So what we're probably going to end up doing is taking the floor plan and importing it into AutoCAD and then scaling it up to full scale to get a general idea of how wide this panel is going, or these panels will be from wall to wall. That will likely vary by the time it gets installed. And why I say that is because when walls are framed, there's a chance that they may not be framed to the exact size that they're shown on the print. So when we do go to draw these in, we're going to be using a VIF or verify in field dimension here for those. And that's going to span from wall to wall. And what that means for you is that it means that the project manager and the building superintendent that we have hired on for the job will go into the building prior to anything being constructed, and they will pull tape measure measurements off the walls and check to make sure what this actual wall-to-wall dimension will be. It's really important that we do that because when we get out to the field and we check all those dimensions, that means that we can actually construct our panels to the exact opening size between these two walls. If we were to go solely based on what's here like if we had a dimension on this drawing and we built the panels to that dimension, there's a slight chance that things might not be exactly that width. So we're going to end up with weird gaps, or sort of like not correct, or the widths of the panels wouldn't be correct to that opening size. So that's what a VIF is for. It's to ensure that we know what that dimension is by the time the walls get built. Even if the architect gave us a dimension for this, I would still put a VIF on there to be sure that the walls are exactly what they say they are. We'll get to that when we go to draw these panels as well. But anyway, as far as the research goes for these panels and understanding what we're dealing with here, the only thing that I think we want to look at next is probably what this material is for the base. SS01. So SS01, we're going to go into the material log in Airtable. And we're going to locate Project Proscenium. It's going to be one of the later jobs right now because it's one of the newest projects on our list. And SS1 right here, it looks to be a 1/2 inch thick. And we'll see if we can find the website for this to see what this is. It's a material by Cryon 6504. I'm going to go to Cryon's actual website here and just research this and see what we've got. Okay, so solid surface sheets. Colors. It is mocha. This one. Okay, so looking at this, the mocha sheet that they offer, 6504, which I believe is the same number we have here. Yep, 6504. They sell it in 6mm and 12mm, which is a 1/4 inch or a 1/2 inch. And we're going to be using the 1/2 inch thick material for this. If you look to the right of that, it tells you what the sheet sizes are as well. So if you have a 12mm thick sheet of this Cryon 6504 mocha material, it comes in sheet sizes of 145 by 30 inches wide. So there is no grain or texture to it either, so that helps us as well. But it's a good thing we do look this stuff up just to make sure that we're able to draw it correctly. And we're showing it a 1/2 inch here, which checks out with what is on our material log right here. So that's good. We need to make a mental note of that. So as we get into drawing these, we do draw this at 1/2 inch thick then too. Okay, so that should conclude essentially the research and development part of what we're dealing with here. I'm going to go into AutoCAD next, and I'm going to open a I got something pulled up already, but I'm going to open up a file. We should be looking for the drafting template for Proscenium. So you're going to navigate to your OSW drive, go down to 6434 Proscenium, go into Drawings, Prelim Project, and you should see that drafting template there is a .dwt file. We're going to open that up. Okay. And right away, before we get too carried away, what we're going to do is start to fill out some of our title block and then save as our drawing here. So like what we've done in the past, I'm going to split screen what we're dealing with here with my drafting schedule. All right. And we are going to fill out our title block. So description here. This will read veneer panels. Oh, you got to be in all caps too. Veneer panels. And then the second portion is the location of where those panels live in the building. That's going to be your level number, room name, and room number. Then you're going to fill out your initials on the drawn by part of the title block. So instead of TBD, I'm going to write JAF. And then we need to fill out our packet number and sub number, 64062. And Oh, sorry, not 6. Oh my gosh. One sec, I got a little dyslexic for a moment. 46062, and then 005. There we go. Perfect. Okay, so now that that's filled out, last thing before saving as, I'm also going to change my tab at the bottom to be my current print reference instead of fx.0. It should be reading p15.0 there. So right click on that tab, go to rename p15.0, enter, and you should be set to go. So now what we're going to do is we are going to save as. Make sure to be careful not to save over your templates. And then when you go to save as, at the very bottom of that screen that pops up, go down to type of file and select .dwg for that file format. And navigate over to the prelim project folder for Proscenium. And we're going to save this here as p15 space hyphen space pkt 46062. And we'll name this veneer panels level 1 lobby 125C. And then, of course, at the end, we're going to put version 1.0 since this is the first draft of this print. Okay, and then once you've got that, you're free to click save. It'll save your file right to that folder, and then you can begin your drawing process. So, yeah. So first things first, I'm going to split screen now this with my Bluebeam, kind of get everything set up to where I'm ready to go. There's my base trim detail. There's my elevation view. And my plan view is right here. And I'm even going to set these up in the same order as what we draw them in. So plan view, elevation view, detail view, or section view. All right, here we go. So as promised, first thing we're going to do is we're going to import the PDF for the floor plan unless we have a CAD file. If we had a CAD file from the architect for the floor plan of the building, I would suggest using that first. One way to find out if we do have one, you can always ask the lead drafter on the project. Or if you're looking for that, it should be either in Prelim Project under Floor Plans A and T, which doesn't look like I have one yet. And if you don't see it there, another place you can look is under Architecturals and CAD Drawings. And if you don't see anything in there, chances are we don't have access to the floor plan CAD file just yet. And that's okay. Sometimes that happens. And what we do with that then is if we don't have that, that information, is we will do what's called an import. So what we're going to do is locate the floor plan we would like to import. That would be the enlarged plan view of the restroom, which is on page A621. Okay, so go back to your AutoCAD, click on New, and we're going to open a blank acad.dwt AutoCAD file. These I just typically use for importing. That way I can manage the layers and make sure I'm not importing extra PDF layers that I don't need. But here's what you got to do. So when you get to this point and you're ready to import that floor plan, you're going to go to import, or sorry, you're going to type in PDF import like that. Okay, then at the bottom of your screen, you should see file here. You're going to click on file and you're going to go find the floor plan from the architectural folder. So architectural folder for Proscenium, we'll navigate to there, drawings, architectural, and we are looking for the enlarged plan of those restrooms. Again, if we wanted to find that again, I got it here pulled up in Bluebeam. It's page A621. Okay, so I just hit open. And when you go to import, if you haven't set one of these up yet, please make sure that you're matching these import settings that you see here. If you need to pause the video for a moment to double check your checkboxes here, please do so. It's really important that we get all these checked and unchecked for what needs to be here and what doesn't. It will help save you a ton of time later on when you go to clean these up at the end. So once you've got those settings set, go ahead and click OK. And you can see at the bottom, it's loading in all of the geometry from that PDF file. It may take a few minutes depending on how large the file is that you're importing. If you're doing a full floor plan, it typically will take a good minute or so. So you may have to go get some coffee or take a short walk or something in between, but it's usually pretty fast, but you do have to be patient with it though too. All right. And once it's imported, as you can see, what I'm doing here is I'm deleting anything that is not needed for what we're dealing with. So we don't need these clouds here. Those are unnecessary. I also don't need to show those. Well, I do need this. That's my wall line, but I don't need the panels that they have drawn because we're going to draw our own. So I'm trying to grab those if I can. We're just cleaning all this up. It will take a couple minutes to do this, so don't fret. This is a part of the game. If you get to a point where you have a bunch of hatching like this, one thing you can do to speed things up is if you click on one of those hatches, you can type in select similar. And when select similar pops up, it will, you hit enter and it will highlight any of the hatches that have the same properties. So you can delete a bunch of them all at one time. Help speed things up for what you're dealing with here. All right, now the last thing is, I got all these room tags, these plumbing fixture tags. We don't really need any of that stuff. So we just really need to do a very good job of cleaning up things that are kind of not necessary. Usually what I try to do is leave myself with the lines of the walls. If there is equipment in the elevation or the drawing that I'm working on, I'll usually try to keep it there, like the bottle filler. I'm going to leave that there. Everything else is kind of just trash, so it's going away. Those are electrical symbols for outlets. Usually you don't have to deal with that in woodworking. But it's important to know what that is, though, if you're ever looking at a drawing and you're questioning what it is that you're looking at there. Okay, almost there. It's got a little bit more to clean up. Got it. Yep, there it goes. Almost there. Okay. Now the rest of the stuff that's outside of these rooms, I'm going to leave that for right now because what I'll end up doing is doing a break line to trim off parts of this room that I don't need to see. I'll show you how to do that here in just a moment. Okay. For the remaining lines that are here though, let's go ahead and highlight everything. We're going to go into properties here and we're going to set everything to by layer. And I'm going to set everything to layer 0. So line type by layer, line type scale actually will read 1. Line weight will be by layer. And once you've got that all set to go, then we are good to copy and paste this into our current CAD file. I'm going to paste this into where my plan view is there. And then one thing I kind of forgot to do is you can see this came out really, really tiny. When you import a PDF, it's going to come in at the exact scale that PDF is drawn at. So to fix that, be able to import this and make it right, what you want to do is pay attention to the scale factor at the bottom of that screen. There's two ways to go about doing this. If I knew what any of the dimensions were for the drawing, I could use the scale command, and I could use what's called a reference scale. So if I scaled all my objects, picked a base point, and then typed in reference, it will ask you for 2 points to select. So if I knew what the distance was between here and here, let's say it was 42 inches, I could set that scale and it'll increase the size of the entire drawing to make that 42 inches there and scale everything up at the exact same rate. Now, because I don't have a dimension to go off of, what I'm going to do is use the scale factor to increase the size of this drawing here. So being that it is 1/2 equals a foot, if you take the number 12 and divide it by 1/2 or divide it by 0.5, it's going to give you a, let's see, 12 divided by 0.5 will give you a scale factor of 24. So you're going to use the scale command one more time, and you're going to highlight that room. And instead of using a reference scale, you can change the scale factor here to just be 24. It's always a good thing to verify and make sure that things look right though too. So if I kind of hover over these doors and I can see that they're about 36 inches, that should be pretty good. Doors are typically going to be 36 to 34 inches wide most times, so that's a good indicator that what we did there worked and we have a scale that's correct to what we're dealing with here. So now that we have that scaled up, we're going to take all these lines, we're going to put them on the existing layer because these are all things that are not provided by Onsite. Then what we're going to do is we're going to throw in those break lines we discussed. So we need to clean this up a tiny bit. So the break lines can be kind of up to your determination where you want to put those. But really what we're doing is we're cropping out the majority of the items that we don't need to see, which don't pertain to Onsite scope. So for us, really what we're focused on is what's happening right here. So I can take a rectangle and draw a rectangle around that part of the room. And then what I like to do is use the offset command. And I'm going to offset that rectangle out, some arbitrary distance, maybe like 18 inches or so. Once I have that, then what I'm going to do is use the break line command. And I'm going to trace over that rectangle with break lines. We have talked about the break line command before, but when you go to start it, it's going to ask you for 2 points. So you always pick the 2 corners of where you want the break line to show up between. And then it's going to ask you for the midpoint of the zigzag or the break symbol. If you don't click on any point, you just hit enter, it's going to default put that break line in the dead center of the break, or the break in the dead center of the break line. So just like that. Once I've put all those break lines in, I'm going to delete that original rectangle we drew and put all these on the dimension layer and get ready to start trimming all these lines away from the breaks. So again, this is more cleanup work, but it's important. Makes your drawing look very tidy and clean if you have all these trimmed to the correct line like this. Anything that's outside of that box we don't care about, we're going to delete those lines. They're not needed. However, there's one here that looks to be like it's giving me some problems, so I'm going to try to see if I can figure that out. I'm going to explode that. And then, yeah, there we go. Now I can trim it. Sometimes when a polyline comes in, it gives you some problems when you go to trim it. So you might have to explode it to get to be able to trim that line. again, I got one here that's also giving me problems, so I'm going to explode that and then trim like that. Okay, everything else, we're trashing it. It's junk, doesn't need to be here. Let's go ahead and toss that. So we're left with these lines here, which is just the doors, kind of the U shape where the walls or the panels are going to be sitting. And there's some cleanup work still to do, like these corners need to be attached. Real easy way to fix that is if you type in fillet and you go down to your toolbar at the bottom, you change your radius set to 0. It will by default connect these two lines with a square corner. I'm only doing that because I want these corners to look nice and to make sure that they are shown accurately. Right now, with that being a gap there, I don't really want to see that. So, all right, I guess I could do that there too, because that's kind of not correct. Okay, that'll work. Okay. So then the next thing would be obviously to throw the panels in here. But I might leave this just for the moment because what I would like to do next is kind of, well, no, we could do the panels first. I suppose we could do that. See how we're doing on time. We're at 41 minutes. Okay, let's try to get as far as we can. We're this hour, and then we'll take a break and then move on to the next video. So, just like we talked about before, with our standard panel construction, we always need to have a 1-inch gap between the drywall and the back of our panel. And that's if you're using panel cleats. If you're using Z-clips or Z-bar, you will only need a 1/2-inch gap between the panel, back of the panel, and the wall. This time we are using panel cleats, so we need to make sure we show that 1-inch gap. What I'm going to do is just drag a line straight across the wall, just like this. I'm going to move that line up using the move command, 1 inch. And then I'm going to offset that line, 0.75. Just like that. Okay, so these will be where our panels live. Now, one thing we did discuss earlier is putting in a full depth reveal at either corner. So one here and one here. The full depth reveal will be 3/4 wide. And so what I'm going to do to make that is I'm going to use my stretch command here. Stretch command, you're going to go from the bottom left to the top right and highlight what you want to stretch essentially. If you accidentally select anything you don't want, all you got to do is hold down the shift key and highlight those objects to remove them from your selection set. Once you've done that, go ahead and hit enter and then drag your cursor or click and drag your cursor towards the direction you want to stretch the item. It's going to ask you what that distance you want to stretch it to is to be, so 0.75 for 3/4 of an inch. Then we're going to connect the dots. Now let's go ahead and do that over here as well. So stretch, highlight from bottom right to top left, deselect any lines we don't want to move, hit enter, click, and 0.75 over. Okay, so that's the start of our full depth reveals. Those reveals will consist of a 3/4 inch block by 1.5 inches wide, so 0.75 thick, 1.5 wide. I'm going to stack that right behind the panel and butt it to the drywall. So there's my line of wall, there's my panel, the back of my panel there. And then between that full depth reveal and the actual wall and the back wall, we need to throw in some shim right there. So we'll add in a 1/4 inch of shim, a 3/4 inch full depth reveal, and then our 3/4 inch panel right there. Let's copy this. Instead of having to redraw it, I'm just going to copy it over to the left-hand side. And then what's left to do is put in the 1/4 inch spline reveals that we talked about in the elevation view. So these 1/4 inch spline reveals, what they are showing here is they want 2 equal panels on either side of the middle of this wall. And in the middle of the wall, they want a 5-foot wide panel. So what we're going to do is we're going to start in the middle and work our way out. So let's go ahead and I'm just going to isolate only the geometry layer. So that way I'm only looking at my panels now because I have these set where they need to be. And we're going to take a line from the very dead center of those panels like this. This will be a construction line for us. And because we know that the middle panel is 5 feet wide, what we need to do is take half of that. So we're going to take 30 inches to the right, 30 inches to the left, and that will give us that 5 foot wide or 60 inch panel there. So offset 30 that way, 30 that way, and that should be the full width of that 5 foot panel now. And you can double check if you'd like to. You type in DI or DIST, it'll give you that temporary dimensional check. You can see that 60 inches now right there. Okay, so the next thing we need to do is get our 1/4 inch gaps in between our panels here. So we're going to offset those 2 lines we just created by 0.25. So 0.25 this way for a 1/4 inch spline reveal, 0.25 that way for another 1/4 inch spline reveal. All right, now we are also going to need one more reveal in the dead center between this reveal and the full depth reveal. How we're going to do that is we're going to take the copy command. We're going to copy that 1/4 inch that we are showing here. And I want the middle of this 1/4 inch. So I don't have a snap point for that right now. So what I need to do is hold down Shift, right click my mouse, and go to mid between 2 points to get there. I'm going to go from this corner to this corner, and then hold down Shift and right click one more time. And I'm going to snap to this corner to this corner here. Let's just verify and make sure that we have 2 equal panels now at this point. So it's DIST, we're checking that. So that panel is 30.20314. This panel is 30.20314. Okay, so we can do the same thing over here if we'd like to. We can also use the mirror command to be able to flip this over to the other side as well. I'm going to do that to give you more of an opportunity to utilize that command. Mirror, what it's going to do is copy something across one center line. So I'm going to use the mirror here, highlight that reveal, hit enter, and it's going to ask you for 2 points of a mirror line. That would be our dead center here. So 2 points on that line. And then when you're done, it'll ask you, do you want to erase the source object? If I click yes, this will disappear here. So we don't want that. We want to click no, so it won't erase those lines and it'll keep both sets. Now that we've got that, we'll delete that middle line. And this is going to set us up for success with our 1/4 inch spline reveal. So I'm using the trim command right now to trim these lines back. And then I'm going to trim these lines to here so that we're dealing with a gap between the panels of 1/4 inch. Just cleaning all of these up one by one. Okay, now if you remember from previous training videos, our spline reveals, they are a 1/4 inch on the face, but the spline itself is 1 1/4 inches wide. If you ever are wondering or forget how to draw that, you can go over to your on-site tool palettes under panels. And if you go to your millwork reveals, you'll see there's a spline reveal drawn there. You can drag and drop that into your CAD file when it loads. And it's going to give you an example of what that 1/4 inch spline reveal is going to look like. So you can see the 1/4 inch gap and the 1 1/4 inch by 1/4 inch spline that sits in the middle. So that's what we'll do. We're going to start by drawing a rectangle for the spline. This will be 1.25 inches wide, 5.25 inches deep. We're going to use the move command, and we're going to move that to be lined up center of these two panels here. So when you start that move command, it'll ask you for a base point. But again, like before, we can't click on the dead center of the spline. So what we need to do is hold down Shift and right click, go to mid between 2 points, and then click each opposing corner of that spline. Now when you look at what I'm seeing here, you have a cursor that is in the dead center of that spline. And then here, we'll hold down Shift and right click and go mid between 2 points once more. And we're going to snap between these 2 points here. This should give us the exact center of where that spline needs to be. And the only thing left to do right now is to trim those lines out. We got to do that for the rest of these reveals though too. So let's go ahead and copy these. I'm using a common base point of this corner here. That way it makes it easier for me to relocate these splines. Instead of having to do the recenter every time, I can just go, okay, that base point's common between this spline and the next one, so I'm going to use that as my copy base. All right, so let's trim these lines like we did before. Clean that up. Just like that. Okay, so now we've got all of our panels, all of our reveals detailed out. I'm going to bring back all my layers by clicking on isolate or the stack of papers with the upward facing arrow right there under my layers. Okay, and that'll do it for the plan view. We're going to come back and hatch these in a little bit, so that way you're actually seeing hatching through these panels, because we're kind of treating it like a horizontal section view through the panels. So we'll take care of that here in just a moment. For now, since we're about done with that, what we're going to do is use the move command, move that plan view to the corner of my view grid right here. Okay, and we are getting close to an hour, but we might be able to squeeze in the elevation view here within that hour time frame. I'm going to go ahead and copy this plan view down. And in order to draw the elevation view accurately, what you want to do is take a copy of your plan view and you're going to flip it using the rotate command. You're going to flip it so it's facing the exact same way as your elevation view. So if I'm standing here looking at these panels, I want these panels to be facing towards me. So you're going to take construction line straight off of that. Notice I kind of just drew one line straight down an arbitrary length. It doesn't really matter how long it is, as long as it extends a fair amount past your view. And then what you want to do is copy those lines throughout. Anytime there is a change in the elevation view, that way, or in the plan view, that way you can translate those from the plan view to your elevation view. Okay, so let's draw a line straight across to represent the floor. And then we're going to offset these lines accordingly, according to the dimensions we are given here. So right now, 10 inches from the floor to the top of the base is fine and dandy, but let's verify that and make sure that the section view on 4A730 also shows that dimension too. It may not, but I just want to just check and see what's going on here to make sure that we're not dealing with conflicting information at all. So it says refer to elevation view for the minimum required, or for this base trim. I guess that minimum required gap is kind of in a bad spot. It's sticking out into this dimension, but they're saying refer to elevation view for the trim, which we saw that was 10 inches tall. So let's offset that line 10 inches tall there. And then it appears that we have, they're saying a 1/4 inch gap. Well, they're saying a 1/4 inch plus minimum required gap on the top and bottom. So The 1/4 inch is the same thickness as the metal, so I know that that can't be true, that this is a 1/4 inch gap between these two panels. What it most likely is going to be is, because I can see this is an 1/8 inch, I bet you this is probably like a 1/16 inch gap, but we'll check it. We might as well. So we're going to go into Bluebeam's measurement tool, and we're going to set our scale to 3 inches equals a foot, and set our scale factor, or our precision, to a 1/16. And we're going to check this out and just see what we're dealing with here. Just as suspected, it looks like they're showing a 1/16 inch gap between the base trim and the metal angle, and that's fine. Probably just an expansion joint. What we're going to do then is we're going to offset that line 1/16 up there, and then we need to offset that line a 1/4 inch for the thickness of the metal. And then offset that line again, another 1/16 of an inch to the start of our panels. Okay. Now let's go back to our elevation view again and see what we're dealing with. So at the very top, we have a panel that's 1'10", so 22 inches tall. And then we have 2 equal panels in the middle. What we need to do is we need to verify what the ceiling height is. It is not given to us here on this drawing, but an excellent place you can look to find that is going to be your reflected ceiling plan. So the reflected ceiling plan will be in the job folder. You're going to see it slightly below your plan view, construction plan, or partition plan. So reflected ceiling plan level 1. We're going to have to locate that room again and just see what that ceiling height is. Here it is right here. So the ceiling in that room, you can see there, that's 14'6" above finished floor. And that's what's going on right here. There's a cove, or sort of like a surround, going into that room. It's a little lower, but this area here is 14'6". What? Oh. It's okay. He's watching a different video. Oh. Okay. Anyways. So the ceiling height in that room is 14'6". So we're going to use that math to our advantage. We're going to go back to our elevation view now that we know that. Make a quick mental note that, let's see, what's 14'6" in inches? That would be 174 inches tall above finished floor. So when we go to draw this, that's going to gauge the rest of what the dimensions are for the EQ panels. Similar to what we did in the plan view, we made these equal by starting with the overall width. In this case, we're starting with the overall height now. So let's go back to our CAD file from the floor. That's our floor line there. I'll offset that up 174. Okay, so that is the line of our ceiling, and that is the line of our floor. So now we know what the margins of what we're working are working in between are. Yeah, so that makes this a little bit easier to work with. What we can do next is, previous videos we have discussed this too, but when you're using panel cleat to attach panels to a wall, you are always going to need a 3/4 inch full depth reveal at the ceiling. That's if there's a ceiling right above your panels, because you do need a small amount of lift-off space to be able to install and uninstall these panels. So when we get to the ceiling here, we need to make sure that we're showing that 3/4 inch reveal. So the next step of what I'm going to do is go to offset 0.75 and bring that line down, just like this. Okay, and that'll be my top reveal. That'll be up here. It's not noted on the architecturals, and usually they do not note those. They don't really pay attention to that because They don't really know what method of install your company is going to use. So they kind of don't account for that typically. You got to watch for that. What we're going to do next is offset the next line down at 1 foot 10 or 22 inches, which will be the next panel. And then in between that panel and the next one down, we have a 0.25 or quarter-inch spline reveal. And then from there, we have two equal panels. So to get those to be equal, there's a couple ways you can do it. The thing that I like to do the most for making those equal is I'm going to copy these two lines that we just made, that quarter-inch spline reveal. All right, and then what I'm going to do is hit enter. And when it says specify base point, we're going to shift right click mid between 2 points. We're going to go between this point and this point here, which will give me the dead center of that spline reveal. And then to make these panels equal, what we're going to do is shift right click again, mid between 2 points. And we're going to go from the bottom of the spline reveal up top to the top of the reveal above the base trim. So right there. Now if I double check with a dist or di command, I can make sure that from the bottom of that line to the top of that line there, we are dealing with a panel of 70.1875. And from here to here, we're dealing with a panel of, 70.1875. So we have successfully made those equal. Then comes the fun part where you get to trim all these lines back to where they need to go. So what I'm going to do is start by selecting the outside panel lines here. And we're going to use the trim command and start trimming away at these until we get to a place where we're more comfortable with what we're seeing here. I'm actually going to extend this back up. I did not mean to trim that. There we go. Okay. Now, another thing I like to do as well is in between these reveals, I'm going to trim these lines out. Just so that way everything looks nice and clean. We're given our exact panel sizes and there's no lines squished in between. So I'm just using the trim command and kind of going over all these little quick little bits here, cleaning that up. Okay. It will take you a quick second to do that. But I'm telling you, you will get really fast at zooming and panning because that's what all you're pretty much doing here. Okay. Boop, boop. Okay. Boop. All right. These, I'm going to trim all these lines back to the bottom line of those panels. So like this. And like this too. That base trim will actually run all the way to the wall. Kind of like what they show here. There won't be a reveal between the base trim and the wall. And so what I'm going to do is take the stretch command and stretch these lines back to the wall like this. And same deal over here. Take those lines and we're going to stretch them back to the wall over there. And just trim this line back as well. And we're getting very close to being done with these, this elevation view now. Just cleaning up a couple last minute bits. And then what we'll do is we'll move the elevation view to where it needs to live in our grid system. And I will pause the video and we will move on to the section views after this. Section views and detail views. Move command, click that corner, snap it there. And then this is my copy of my plan, so I no longer need that. We can delete it. And go ahead and save here where we're at. And we'll stop back in just a moment and finish the sections and details.